Okay, so that's number 7. Number 8 is asking us if a polynomial function f of x has roots of 4 minus 3i and 5, what must be a factor of f of x? So let me take out 8. Yeah, this is 8 here. Yeah. So if a function has the roots, so let me list the roots here. So roots here are roots are 4 minus 3i, and 5. So it's asking what must be the factor of f of x. So it's asking is a factor of f of x here. So as you can see, we have 2 roots here. If we have 2 roots, we have 1 root here and 1 root here. This must be a quadratic function here, right? Because again, a quadratic function has a maximum of 2 roots here. So we could assume this is a quadratic function. However, we could have actually a higher order polynomial and with only 2 roots here. But for the sake of this problem here, I'm going to assume that this polynomial here is quadratic. So if it's quadratic here, and I know here I have 2 roots here, I can simply say that f of x here equals, I can say that it's going to be x minus 4 minus 3i. And then I have here, and 5 here, right? So again, I have here, x here would be minus 5, because again, this is a real root. 5 here is a real number, it's a real root. And 4 minus 3i here is actually an imaginary root, right? This is written in terms of in a complex number here. So in this case here, we have this is a complex root here. So if you know from complex numbers, in this case here, 4 minus 3i here, the conjugate or the complex conjugate of the root here is also a root as well. So we can say that 4 minus 3i is a root, but we have to also assume that 4 plus 3i here is also a root as well. And knowing that I here is the square root of -1, right? So this here is also root. So therefore, we can say that our real root is obviously 5, so x minus 5. We're going to multiply this by x minus 4 minus 3i, and obviously x minus 4 plus 3i here. So this here is our polynomial solution here, and this will not be our quadratic now. This will now be a cubic function because of the inclusion of the 3rd root here. Or it could be a cubic function, but we don't really know in this case here. So this is 4 plus 3i here. And this here is our, these are the factors of the polynomial x. And as you can see, hence x minus 5, x minus 4 minus 3i, and x minus 4 plus 3i here are factors of the polynomial. So these are all factors of the polynomial function. So this solution here is correct. Factors of polynomial function. The tricky part of this question here is simply just this complex root, right? We have this is a complex root here. And the moment we see a complex root, we have to also care about the conjugate root, right? So 4 minus 3i, the conjugate root is we just simply flip the sign here. 4 minus 3i becomes, and we have to also include 4 plus 3i here. So this solution here is correct. Solution correct. Good analysis here. And this is number 9 here. So that's guess a Norman window has the shape of a rectangle with a semicircle on top. See diagram. If the perimeter of the window is 30 feet, sorry. Find the dimensions of the window with the greatest possible area. Round your answers to 1 decimal place. So this is actually this is part of a grade 12 calculus question here. This is the concept of optimization. So basically what we're going to have to do is we have to first draw a diagram. So let me draw a diagram first. So we have a shape of a rectangle with a semicircle on top. So it probably looks something like this here. And then we're given the perimeter here is equals 30 feet. And we want to find the dimensions of the window with the greatest possible area. So greatest possible area, we want to A here, and we want to maximize this guy here. Maximize our area here. It says round your answers to 1 decimal place here. So as you can see with the solution here, the solution is not very good. Again, it just tells us what to do here. It doesn't actually give us a solution here. So let me just read this for you as well. So it says the area of the window can be computed as a sum of the area of the rectangular portion plus the area of the circular portion. So this here is correct, right? So when we're talking about the area of the normal window here, do this in blue here. The area, or this area total here, is basically equals the area of the rectangle, which is I can say here's the blue, this blue part here, is the area of a rectangle, which we know as its length times width, right, of our area, plus the sum of the semicircle, right? So I can say it's the area of our rectangle here and the area of our semicircle AS here. So total area is simply just length times width plus I have area of a semicircle. So if I know area of a circle is pi r squared, the area of a semicircle would have to be half of that, right? So it's gonna be half pi r squared here. So this will be our area total here. So knowing this here, we have LW plus half of pi r squared here. In this case, this here is the radius of our circle, right? In this case, the radius of our circle, this here is the radius of our circle, but it also equals our length, or the width of our rectangle here, right? So I can actually replace this r here with w, right? So this is going to be AT here equals length times width times half times pi w squared here. W squared here. And so what we have here is we have our area equation, which is perfect here. So this here is correct. So in other words, it says this is the first part here. So I've written this out mathematically, and they did include that. That's okay. So it says, in other words, since and let us denote the area of the window. So we have, oh, these are not proper sentences. It's okay. I'm going to see if I can. Now observe that the minimum value of the height and the maximum value that can take is when. So we have to maximize the function in their interval. We find the derivative and the critical points by solving something. Since the critical point lies within the interval, and to find the maximum area, we evaluate the critical point and the endpoints. This implies that the maximum area and obtained when the radius is height is something. So clearly, this is a copy and paste of something that was actually like something else, but I don't think everything copy and pasted. So unfortunately, we don't get the answer for this problem. But what we can do is we can simply just solve it, right? So again, we have our area formula here, and what we're gonna have to do in order for us to maximize our area, we have to take the derivative of this function here. So we're gonna take the derivative in respect to with respect to our a here. So I'm gonna say here, we're gonna take the derivative of this. So I'm gonna say a total prime here, this will be the derivative here, equals, and I can take it in with respect to, in this case, probably in respect to width, because I can see I have w in terms of both, on both terms here, w in both terms here. So if I take the derivative of that, I would get the LW just simply becomes L, and then plus I'm going to bring the 2 down here. 2 times half here equals 1. And then I still have pi obviously here. And then this would just simply be pi times w here. So this here is the area prime, or the derivative of the area here is L plus pi w here. And what we can do is we're actually given our perimeter formula as well. Our perimeter formula, actually let me label this as number 1. And number 2 here is we have our perimeter formula, right? We know that P here equals the perimeter of the formula. The perimeter formula is simply is equal to 30 feet, but we know that perimeter is simply just the perimeter around the rectangle, right? So we can say it's one length here plus one width. This guy doesn't count, right? This length here doesn't count, and we care about this semicircle here, right? So we can say here it's simply just the 2 lengths plus a width here, because we only care about the one width. This here is inside the circle, so we're not going to count the perimeter of this guy here, and we care about basically half of the circumference of the circle. If a half of circumference, and we know the circumference of the circle here is pi or 2 pi r, right? 2 pi r. If we want half of the circumference for half of because this is circumference of a circle, we want circumference of a semicircle. So this is simply would be pi r, right? Okay, multiply by that half. So this here would be pi r here, and we know that r here equals w, right? So r, I can say that it's simply just pi times w here, and we know that perimeter here equals 33, right? So I have 2l plus w plus pi w, right? So again, I have here a formula for basically my perimeter and my area. What I can do is I can isolate for one of these variables here, right? So for maybe in this case here, I'm going to isolate for the second equation. I'm going to isolate for my length here. So I'm going to move pi w and w to the other side. So I'm going to have 30 minus w minus pi w equals 2l. I can say l here equals 30 minus w minus pi w all over 2, right? So this here is my length equation. What I'm going to do is I'm going to substitute this equation into L here to solve for, so I can solve for my W here. So I'm relating it to one equation here. So I'm going to get here, I'm going to do this in blue. So in this case, I would get A prime at t would equal the length, which is 30 minus w minus pi w here, all over 2 plus pi w here. And then what I can do is I can simplify this equation here. Let me just think about how I would simplify this equation here. So I can multiply. I can get rid of this 2 by multiplying basically this entire term by 2, and the area by 2 as well. So I can say that this is now 2 area here prime equals basically 30. I would have to do 30 minus w minus pi w plus, and then 2 pi w, right? Because I have to multiply this side here by 2, right? Plus 2 pi w, and then I can simplify 30 minus w here. So I have minus pi w plus 2 pi w here. So this would be, you can think of this as imaginary 1 here. So this would be simply just positive pi w, right? W here, and then all over 2, right? If I want to move back the A prime back to this side here. So this here would be another formula. What I can do is I can set my area here to 0. Right? If I set it to 0 here, I can solve for my maximum, for my critical point here. So if I set A prime here to 0, I can solve for my width here. So if I set this problem to 0, because if I set it to 0 here, I'm solving for my critical points, which is both the maximum and the minimum point because it's telling us to maximize our area here, right? So if I set it to 0 here, I'm going to get 30 minus w plus pi w here all over 2. I can simply just put 0 here, 30 minus w plus pi w here. I'm going to bring 30 to the other side. I can get negative 30 equals w plus pi w. In this case, I would get I can add both of these guys here, right? So I have negative 30 here. It's going to equal basically 2w pi, or 2 pi w, right? 2 pi w here. And then I can divide that. I divide both sides by 2 pi to get my w here. So w here is equal to negative 30 divided by 2 pi here, which would equal basically some number. So negative 30 divided by 2 times pi would give me negative 15 pi, which is negative 47.12. Negative 47.12. And of course, width here can't be negative, right? Width here can never be negative. So it means that in this case here, width has to be positive here. So 47.12 would be my width. And then what I could do is I can substitute this guy for my length here. Yeah, I can substitute here for my length here. So to solve for my length, so if this is 47.12 my length here would be, let me just solve this guy here. So length here would be L equals 30 minus negative 47.12 minus pi times negative 47.12 all over 2. And what I would get here, a very, very big fraction, I'll just use my calculator. So this would be plus 47.12, then plus pi times 47.12 minus pi times negative 47.12, and then divided by 2. This give me a length of 112.5 feet here, which I don't think that makes sense because my perimeter is only 30 degrees, so something 30 feet here. Something is up with this problem here. So let me just double back and see if we made some errors here. So I set up my equation here. I found the derivative in terms of. Let me see if I wrote the diagram correctly here. Let me just download this image. I just want to see if this is the correct image. Just give me a second here. This is the correct image here. So that makes sense here. So okay, so I guess here in the radius of a circle here is not this guy here. It is this guy here. So I actually took the diameter. So there's my fault here. That's why my numbers were so big. So in this case, this is the height. This is 2r, and this here is r here. So I actually messed up here, and I actually put, instead of the diameter, this here should have been. This here is not the width. This is actually the diameter here. So what I have to do is I would have to actually modify these numbers here. So instead of getting half r squared here, I would get basically. This here would be 1 quarter pi 1 quarter pi w squared here. Let me just double back here. Let me just think about this here. LW plus half pi w squared. This would not be correct here because the radius here is not this guy here, so it's not this here. The radius of the circle is from here to here, right? So this here is my r, which is half of my width here. So I can say this is half of my width squared here. So this here is a much better algebraic expression, which means unfortunately I did my derivative wrong here. So let me just erase these guys here. Let me take the derivative again. So I have AT at prime here equals LW. So I'm taking into respect to W here. I would have L plus, or let me simplify this before I take the derivative here. So this here would equal LW plus, I have half times half here, or let me see, I have half of w squared. Yeah, okay, that's good. So half of pi here. I'm going to expand these guys here. Half w times half is 1 quarter w squared, right? So, and then what I can do is I can do LW plus half. I can multiply in. So half times 1 quarter is simply 1/8 of pi w squared here. This would be my new AT. I'm taking the derivative here. Let me just erase these guys here. Should have clicked the picture now. I kind of regret it, doing all this work for nothing. But a prime here equals, again, I'm taking the respect to w. I have L plus, I have 1/8 here pi. Or I have w here. I'm going to move this 2 downwards. So 2 times 1/8 here becomes 1 quarter pi w here. And this is the derivative of my function. I'm going to set it to 0, which equals L times 1 quarter pi w. And this here would be my the maximization of my area here. I believe I would have done my perimeter wrong here as well, because 30 feet is the perimeter of the entire thing. I'm going to add 2L, 2 lengths, 1 width, which is good, and I'm adding 2 pi r, right? Or half of 2 pi r, which is basically just pi r here. So pi of the radius here. Pi times the radius, sorry. Or pi times the radius here. 30 here equals 2 length plus width plus pi. And we know that the radius now is actually half of w, right? So half of w here. So I can say that 2 length plus w plus half pi w here. And then what? And then this here would equal, this here now equals 30. So let me, oops. Let me just erase these guys here. I have 2L plus half pi w here. And then I can simplify this by saying 2L plus, I have 2 w's here. So which I can say that I have half times 2 pi w here, which is simply just 2L plus 2. These two cancel out, so I have pi w. So, yes, I believe, oh, actually, hold up. I'm adding these guys here. I have pi plus 2 pi plus half pi w. Yes, so I would have half of pi, which is 0.5 times 3.14. Give me a second. It's 1.57 plus 1 here. So I would get, give me a second. We get, you can think of this as 2.57 w here, or you can just leave it as is. It doesn't really matter here. Basically here I want to isolate for L, right? I don't really care about these guys here. So if I want to isolate for L here, I can simply move all the w's to the other side. So I have 30 minus w minus half pi w equals 2L. Finally, L here equals this monster of an equation here, right? L equals 30 minus w minus half pi w all over 2. And then now I can substitute this into the equation here. So let me erase this. So this would probably be a thinking question in terms of grade 12. So this here equals 0. This is length, which is 30 minus w minus half pi w all over 2 plus 1/4 pi w, right? I have 1/4 pi w. What I can do is I can multiply both sides by 2. So this here is still 0. I get 30 minus w minus half pi w. In this case, I can multiply this term here by 2, right? And this here would give, I would get half pi w here. These two guys cancel out. Pi w and half pi w cancel out. So 0 here equals 30 minus w. And then I would get negative 30 equals negative w, and w here equals 30 here. So in this case, my width would be 30, and my length here would be, I'm going to just type this into my calculator. 30 minus 30 minus half pi times 30 all over divided by 2 here, which I would get negative 15 over 2 pi would be my length here, which doesn't make sense because I actually get a negative, number again here. Let me just look back to our equation here. And we're going over time now, so it's okay, but I'm kind of determined to finish this problem here. So I'm just thinking about how we could figure out this problem here. Again, I have 30 minus w squared here, which is good. And let's see here. Area of the semicircle is half of pi r squared, and r is half of width, which here, if I squared both of those terms, I would get 1/4 w squared. I multiply half by a quarter, and this would give me 1/8 pi w squared here. So I might have to actually come back and do this problem, just because we've run out of time here. So let me so I might have to come back and do this problem for you as well. But I guess we'll pick off this problem. We ran out of time. We will look at this problem again, actually, probably in the next video, and I think we'll redo this question just because I took way too much time looking at the radius of this problem here. And how it was different here. So I'll come back to this problem and we can verify the solution for next video. So sorry about that. Kind of a buzzkill here, but I'll redo the solution here so that we can look at the solution for next time here. So thank you so much for watching again. If you found this video intuitive, you can definitely follow the OneClass YouTube channel, and we'll be able to kind of get started on that, and we'll be able to kind of help you out in terms of math problems or chemistry problems though. As always, thank you so much for watching. Stay safe, stay healthy. Have a great day.